All right. In this video, we're going to be taking a look at statistics. Our last two chapters deal with statistics, so we're going to move a little bit away from algebra. There'll be a little algebra in here, but most of the hard algebra is behind us. But we're going to look at statistics, and this is a definition from our book right up here. Statistics is the art and science of collecting, analyzing, presenting, and interpreting data. It provides tools for predicting and forecasting the use of data through statistical models. Now, given the current time we're in with the coronavirus, you've probably seen things about flattening the curve. It's a very famous statistical curve. There's a lot of statistics going around, infection rates, deaths, fatality rates, all sorts of things like that. Statistics are a big part of healthcare and actually a big part of most fields. Statistics do show up in just about every field of study and other places, things like sports, advertising, and again, like I mentioned with the coronavirus, but we're going to just focus on some simple basic ideas. Now, the word statistics can get used to refer to the individual pieces of data, the numbers, but also the field of study, the science of data. So statistics can be used in all kinds of ways. We're really just going to touch the surface of this in this course, but we do offer a full semester course with this O82 as a prerequisite on statistics. And if you're in some of the social sciences, if you're in nursing, a lot of times you're doing studies where you're looking for different treatments and seeing how effective they are. Those are fields where statistics would be used quite a bit. Okay, we're going to focus on the basics of statistics, and we're going to start off in this section looking at the data. Okay, so the question really here is, what is data? Well, in statistics, data is the information we record and use to analyze. Okay, data can be things like numbers, right? Heights, weights, incomes, grades, or it can be non-numerical. Things like gender, hair color, major, all sorts of things. Now, in the universe of statistics, rather than using terms like numerical and non-numerical, we're going to talk about quantitative, which is numerical, versus qualitative, which is categorical, okay, or non-numerical. Okay. So when we talk about numbers, heights, ages, weights, incomes, grades, blood pressure readings, things like that, those would fall under quantitative data. And one nice way to think about if you get these confused, they're very similar words, quantitative and qualitative. Think about the word quantity, right? The word quantity is a number, how many you have. So I always think of quantitative as the amount. Qualitative is a description, right? How good is something? That's what we think about quality. So we've got qualitative categorical data. We've got quantitative numerical data. Okay? Now, there's one important thing to discuss here. We're talking about data, and we also have variables. Variables in statistics are very different from the X variables we've been studying in algebra. Variables represent the characteristics that describe things. So here's a summary of some data. We're going to, rather than focus on definitions, which, I'm not going to ask you definitions, but I think it's important to understand, we're going to focus on looking at this data that might have been collected, a very small sample here. What is data, right? This down here, this is all of the data, right? It's all of the information that we've collected. Now, what have we collected information about? Well, these are the variables that we've collected information about. So when we look at statistics and we talk about variables, right, we're talking about the characteristics. What's the person's student ID? How many credits are they taking? What's their age? What's their major, right? We could extend this to full-time, part-time status. We could extend this to, working, any characteristics about the student. So the individual students give us the data. The data is the numbers or information, right? Because credits and age are numbers. The major is information, right? And the variables are the things that the numbers come from, right? The characteristics of the student. Okay, so I'm not going to ask you for definitions, but you're going to see questions in this section. We're going to first learn how to distinguish between data being quantitative or qualitative, and then we're going to look at different types of quantitative data. Okay, so in this case, we're looking for quantitative or qualitative data, and here's a bunch of characteristics. Okay, so each of these characteristics here, these variables, right, we want to be able to describe as either quantitative or qualitative. Okay, so remember, quantitative, quantity means it's a numerical measurement, something you can measure, right, something you can compare. One is bigger than the other, one that you can measure somehow, right, put in order. Qualitative is something you can describe. Okay, in general, quantitative is numbers, but we'll see one sort of situation where that's not entirely true. Okay, so let's think of hourly wage. Right, we look at this first example here with hourly wage. Hourly wage is a number, right? The higher your hourly wage, the more money you make. So we're going to describe this one as quantitative. Okay, number of siblings you have, right? Some people have 3 siblings, some people have 5 siblings, some people have 10 siblings, right? The more number of siblings you have, right, the bigger the family you are. So that's also quantitative. Oops, I got one extra one there I don't need. Okay. Marital status, right? Single, divorced, married, widowed. That's a marital status. We can't say one is bigger than the other, one is smaller than the other, right? They're just verbal or written descriptions, so we would consider this to be qualitative. Your eye color, right? Blue, brown, black, green, hazel, right? Whatever your eye color. Again, those are not things we can compare or rank, right? So this would be considered qualitative, right? Number of books read this year. Anytime you see number, right? Number of siblings, number of books, it's pretty clear that we're going to be quantitative. Just want to leave that copy behind. A career field, right? Think about your career. It could be in allied health. It could be a scientist. It could be a grocery store worker. It could be any career, imagine dental hygienist, teacher, whatever, right? But again, those are not things that can be ranked or compared, right? Qualitative. Age is quantitative, right? It's a number. Okay. Now this last one is one of the ones that's a little bit tricky sometimes, student ID number. Okay, it is a number, right? But if you had a student ID number and another friend of yours or colleague or classmate had another student ID number, it wouldn't make sense to try to compare those or look at the difference between them. Even though it's a number, it's not really a meaningful number. It doesn't measure anything, right? You can't turn your student ID number, the digits in it don't mean anything about you, right? Things like phone numbers and zip codes and things like that, you would never subtract 2 zip codes and try to make sense of it. So even though it's numbers, that would be considered qualitative. Let me just leave that one behind. So most of the time it'll be pretty clear. If the number is a code of some type, then it's technically not a quantitative piece of data, it's qualitative. Okay. In the next section, we're going to look at qualitative data, and then we're going to move for the rest of the semester looking into quantitative data, numbers. Okay. So you have some practice with these. They're not so bad once you get the hang of it. Sometimes you just get the words confused, so try to remember quantitative is quantity. Okay. Now, in addition to quantitative versus qualitative data, once we get to quantitative data in the future, we're going to have to look at the difference between discrete or continuous. Okay. Now, the word discrete means sort of distinct, right? And when we think of discrete, we want to think of things like the integers. There's 1, and then there's 2, and then there's 3, and then there's 4, and there's really no in between, right? Now, real numbers, there's in between, right? But if I was counting how many siblings you had, you could have 1, I mean, you could have 0, right? But you can't have 1.5, or you can't have 2 1/3, right? So we think of discrete data, right? We're talking only about quantitative numerical data here. Discrete is when there are individual values with nothing in between them, right? If you can sort of think of them as integers. Continuous would be something like your age. Now, most people think of our age in numerical terms, or our height in clear integer terms. But technically your age is based on how many days into the year you are, right? So you could be, 20.5 years old, right? Your height might be 56.137 inches, right? So what we're going to look at is once we decide and recognize that we have quantitative data, in the future we're going to need to distinguish between whether it's discrete or continuous. Now the easiest thing numerically to look at, if you see decimal or fraction pieces, then you are continuous. If you don't see decimal or fraction pieces, but you could put them in, right, then it's continuous. If there's nothing in between the values, if you're just counting things up, then it's discrete. Okay, so this is a little bit harder, but let's take a look at a few examples. Your hourly wage, right? Your hourly wage is going to be continuous. Okay, your hourly wage is continuous. You could make 4.7. That's pretty low salary. $8.93 per hour. It could be $12.72 per hour, right? There's no sort of clear separation between values. It could be anywhere in between. It generally has decimal values, so we would consider that continuous, right? Number of siblings, I already sort of addressed this in the last slide, right? You can't have parts of a sibling, right? You can't have a half or a third. Now, we do have things technically like, step siblings or half siblings, but that's not something we would count here. So sometimes we have to be a little bit careful, trying to be too technical about it. Okay, your age. Again, I mentioned this in the last slide. Age is continuous. Every minute of every day, your age is changing. We don't necessarily think of it that way, but it is. The amount of coins in your pocket, right? It could be 0. You could reach into your pocket and find a bunch of coins, but you can't have a part of a coin, right? So we would consider this to be discrete. Okay. All we're really doing in this section is starting to look at data. We're going to be given data. We're going to be given variables that measure the characteristics of the data. And we're going to have to do two things. We're going to first have to decide if data is either quantitative or qualitative. And then if the data is quantitative, we're going to have to decide whether it's discrete or continuous. Okay, so make sure you go through the homework practice. It's not that complicated, but it does take a little bit of repetition to kind of really get it down.